So we're going to show how graphing an equation from a line and equal values method will both give you the point of intersection. You can see both of them listed here. We're going to zoom in on graphing, and we're going to start with the red line. And of course, 2x is our growth rate, and the plus 3 is our starting point, or y-intercept. So we're going to start there. We're going to put a red dot at 3 on the y-intercept right here. And then 2x tells us we go up 2 and over 1. 1, 2, over 1. 1, 2, over 1. 1, 2, over 1. 1, 2, over 1. You can see that it just keeps growing. We're going to do the same thing now with the blue line, which is negative 2x plus 15. So 15 is our starting point. So I'll put our first blue dot right there. And then negative 2x means we're going to go down 2 and over 1, and then down 2 and over 1, then down 2, and then over 1, and down 2, over 1. You can see this line just keeps going. I'm not going to draw the line because the tool is a little unwieldy. However, we can see where they cross. So let's label that our point of intersection is at 3, 9. We can see it right here. That's how we find it graphing. Now let's find it algebraically. So I'm going to squeeze this down a little bit so we can see both things at once. Okay, you can see I've put the equations in already. And I wrote 2x plus 3 in red and negative 2x plus 15 in blue so that they match. This is just an algebra equation, so I'm going to draw the line down. We need to isolate x. So the first thing is move x's to one side. I'm going to add 2x on the right because a negative 2x and a positive 2x will make a zero pair. And that will help us isolate it. And since I did it on one side, I'm going to do it on the other. So now we have 4x plus 3 equals 15. Again, we're trying to get x by itself or isolate it. So now we're going to move the units away. So instead of plus 3, I'm going to do negative 3 because that will make a zero pair. If I do it to one side, I'll do it to the other. The zero pair allows it to disappear. So now we have 4x equals 12. But I don't want 4x's. I want 1x. So I'm going to divide by the value in front of x, which is 4. If I divide on one side, do it on the other. This gives me a 1. So now I just have x equals 3. To find the y value for my point of intersection, I'm going to rewrite the equation y equals 2, but instead of x, I'm going to substitute it with my new value, 3. And so now I have y equals 6 plus 3, y equals 9. Now let's try it with the blue equation. Y equals negative 2x plus 15, except instead of x, we're going to substitute with our x value of 3. And we get y equals negative 6 plus 15, so we get y equals 9. And as you can see, we have the same value for y, both equations. So once again, we have determined that x is 3 and y is 9. We get our 3 from right here, and we get our 9 from right here.